All right, line B1, learn task 11, braking methods. And the first thing we need to go and state is that braking just follows the first law of thermodynamics, which states that energy can neither be created nor can it be destroyed. It can just go and change form. What we are going to primarily see is that we are going to go and change form into heat. Is going to be our primary way that we're going to be able to go and get rid of electrical energy. We're going to have friction or electromechanical braking. We're going to go and have plugging, which is going to go and cause heat in magnetic circuits. We're going to have dynamic braking, which is once again going to cause heat in magnetic circuits. We're going to have regenerative braking, which is going to go and cause heat in other loads. We're going to send it back to the system. It's going to go someplace else. And last of all, we're going to go and have eddy current braking, which is also going to be a form of heat that we're going to go and pull off. The first one that we're going to start with is going to be friction or electromechanical braking. And at the very beginning of this one, I have to be quite clear about the terminology that they're using inside of here. You're going to go and see the word retarding as it is properly used in English. I know that it can be used as a slur. That's not what it's being used as here. It's not any sort of ableist poking fun at anybody or anything like that. Retarding literally means to slow down. And we are primarily going to be trying to slow down the motors. Not every one of these are we going to actually brake to a standstill. Instead, we are going to go and provide a retarding force, which is going to be a slowing force to go and speed up the slowing down of that motor, so to speak. So don't get too caught up in just the terminology off of this one. It's not put in here because they want to go and make a point or be offensive or anything like that. This is just the proper English term for it. First one that we're going to look at is going to be this friction or electromechanical braking, and it is going to be used to either, and the very first sentence here, retard the speed of the motor, so slow down the speed of the motor, or stop the motor completely. There's a huge difference in that statement because we have got some types of braking that are not going to be able to actually physically stop. They can only go and provide a slowing down force, but as soon as that motor has been stopped, they don't have any sort of a stopping force. My friction or electromechanical does provide a stopping force. Now, most of these are going to go and be spring applied, so they are going to go and be released by springs and electromagnetically take it offline. Or we're going to say we're going to release the braking force by applying magnetism, which is going to unclamp the brake, and then when we go and take away power from that coil, then we are going to automatically apply the brake through the use of springs. This gives us a fail-safe. So if we have any sort of a power failure, then our braking is automatically going to be applied. The motor's going to stop anyways because, we've lost power. So we might as well go and brake that thing down right away. First one that we're going to look at here is going to go and be our drum brakes. Drum brakes are going to go and have a large drum that is going to be placed onto the shaft of the motor. So right now we are looking end-on into the motor shaft over here. You can see the little keyway on there, and it's going to be a fairly wide drum. And around either side of that drum, we see that we have got these two components over here, which are going to go and be a brake shoe. That brake shoe is going to be aligned with a friction-forming yet heat-resistant type of brake shoe material. A lot of our older ones had high concentrations of asbestos. Be very careful when you're working around these friction brakes. Newer ones, they definitely cut down on that, but it's still not a good thing to get any sort of brake dust, whether working on vehicles or working on electrical equipment. You want to try to avoid getting brake dust into your lungs. So just use common sense. Use a respirator when you're working around these things because they do have a lot of nasty dust that's going to be built up on them. The way that these things are going to be applied is we are going to go and have a movable arm. That's going to be this whole assembly over here, which can move in or move out. Now we've got a spring that is going to go and try and push it out. And when we go and energize the coil, electricity is going to try and push it in, or pull this thing in. So whenever we would go and energize this, the electricity is going to pull this in, which is going to push that bar in that direction. As it pushes that bar in that direction, it's going to go move that shoe off of the actual drum. As soon as we go and release the electricity, shut off the power to this thing, then the spring is going to go and reverse that direction. The spring is going to go and push this thing out. You can see the spring coiled inside the center there. And as it pushes out like that, it is going to go and clamp these drums up against the side where they're going to go and ride up against the side the way that a brake is supposed to and dissipate energy as heat, allowing us to stop them. They are going to go and provide a huge benefit in the fact that these things, when we have to shut off power, not only are they being used to retard or to slow down the motor, but they're also being used to permanently stop the motor. Once the motor has quit rotating, it is going to be held in position by the force that we see off of these two shoes over here. We've got another type of brake that is similar, that is going to go and be a band type of brake. A band type of brake is going to go and have, once again, it's going to be a heavy gauge type of material, like a really thick, almost like fire hose type canvas that you're going to go and see off of these things. Or in some cases, it's going to go and be chain, and it's going to be anchored. So draw it over top of this thing over here. It's going to be anchored going around like this, and then it is going to be attached to our arm that is going to once again try to pull away anytime that we release this thing. And on the inside of this band, we're going to go and have a bunch of smaller pads that are going to be placed inside of here. Once again, as soon as we go and release, as soon as we provide power, then this thing is going to slack off. Our drum can rotate on the inside. As soon as we lose power, this thing is going to go and pull with the spring in that direction, which is going to go and tighten that band up against the side. This brake is a directional brake. We need to go watch which direction our rotation is going to go and be. What we want to do is we want to be pulling the band from the anchor. This is my anchor point over here. I want it to be pulling like that, because if it's going like this in the opposite direction, it's pulling against the spring, and you get a lot of chatter and a lot of bounce that can happen off of them. So you do have to physically reverse the braking off of those ones anytime that you reverse the rotation off of those. Disc brakes, less commonly used in electrical than they are used inside of automotive. In automotive, we like disc brakes. In electrical, they're just less commonly used, but it's just going to go and be a sideways disc. Instead of us clamping on the edges the way that we are here on the drums, we are then going to instead going to go and have thin discs, and we are going to go and apply side pressure. We're going to have pads that we're going to go and squeeze up against either side of these ones. We sandwich that disc in between our two brake pads themselves. Any one of these brakes, the drum brake, the band brake, or the disc brake, can be applied with the same type of circuit. They do specify that this is, the control of a friction brake, although the module says that this is for a disc brake. It could be for disc, band, or drum brakes. What we see is that we have got a solenoid that is going to go and release my motor. Now, if I go and erase these over here and these over here, it should be pretty obvious to you that this is just a standard 3-wire stop-start type of circuit that we're seeing on here. When we go and press our start button, the M coil is going to energize, seal itself in. We're going to go and continue running. All that we're doing is we're adding in a solenoid either in parallel with the M contact, which is one way that we can do it. So now when we go and energize our M coil, seal that in, we'll also energize the solenoid coil, which would release the braking. That's one way that we can go and do this. The other way that we can go and do it is we can, this one over here, we can go and apply it at the motor itself. This is where we're going to go and take this thing off of the line, the solenoid itself. We'll take it off of the lines of the motor itself. So if I've got a 600 volt system over here, I would need to go and have a 600 volts solenoid. If I've got a 120 volt system and I'm using a 120 volt control circuit, then I would have to go and stick, 120 volt coil inside of here, etc. Doesn't matter which one. Either way, we see that the second that we would apply power, even in this one over here, we apply power, we would instantly carry through here. We would seal in my M contact like that. And then at that point, those again, that would close in all of these. As soon as it closes in all of these, we would see that the solenoid would be receiving full power, and therefore it would release the brake itself. The major advantage to a friction brake is that the friction brake holds the motor shaft once we have shut power off. It's going to be spring applied, right? So as soon as we stop that motor, it is going to go and stay locked into position. There's also not a lot of control that goes along with it. We just have to pick up a spot that we are going to go and place our solenoid, like what we saw in here. We pick either directly on the lines themselves or in the control circuit based upon the voltage rating of that solenoid. And it's automatically applied whenever we get that power failure. This is just going to be a fail-safe. If stuff shuts down, we automatically go into braking. As well as our brake cannot reverse the motor. This might seem like a dumb benefit, but later on, once we go into some of the other ones, plugging and other methods of deceleration braking, we'll see that if we accidentally do the braking wrong, we can actually start rotating in the wrong direction. The disadvantages, maintenance. Anything that has got brakes on it is supposed to be maintained. Guaranteed there's at least one of you in the class right now that is driving around with squeaky brakes out there because you are skipping on maintaining your brakes. All that means is that, it's going to be less effective at stopping. Same with these over here. The pads are going to need to be cleaned out, whether we're dealing with disc, band, or drum. The friction pads need to be maintained before we allow them to go and wear all the way out. We also have got a couple of adjustments. This over here will allow me to go and drive this pad closer. As that pad wears down, I can start moving it closer and closer to the drum. And I can also go and adjust off of this one here for different, amounts of clearance. Once again, based upon wherever that motor is operationally. So, periodic maintenance, the brakes themselves are going to be large and costly. They do take up extra space. Wherever we have got our motor, we now have to provide space for that brake that's going to be right next to it. And we also have to make sure that it's going to be suitable. We cannot be, burning off asbestos if we are working inside of a flour mill or something like that, because then it's going to end up inside of the foodstuffs, right? So you have to watch, where they're going to be placed, etc., as well as the materials themselves can be hazardous. They don't mention it inside of here, but once again, a lot of these are going to be made with asbestos and other types of mineral components that are just not good when they get powdered. And anytime that we wear like this, we are going to end up with powdered metals and mineral components, which should not be breathed in. So you want to make sure that it's safe for your customers so that they don't sue you down the road later on for them breathing into the brake dust, as well as if you are maintaining them, that you're taking the extra precautions, wearing a mask, etc. Okay, that is it for our friction brakes. We are going to go and move on next into our plugging brakes.